Welcome to the Explainer. So artificial intelligence feels like absolute magic right now, doesn't it? I mean, it writes our essays, it generates these mind-blowing pieces of art, and, it even drives our cars. But if we look past all that sci-fi hype, past the glowing user interfaces and those seemingly endless capabilities, there are absolutely no conscious minds at work.
Okay, let's dive right in. Because the truth is, AI just isn't magic. If you were to strip away the thousands of lines of code, you aren't left with some futuristic digital brain. No way. You're actually left with a massive collection of addition, multiplication, and calculus, all operating together at absolute lightning speed. So today, we're cracking open that black box. We're going to look at the exact math that machines think. To make sense of all this, here's our roadmap for today. First, the illusion of magic. Second, the core artificial neuron. Third, the 3 pillars of AI math. And finally, number 4, the ultimate learning loop. Let's get to it.
Section 1, the illusion of magic, where we'll clear up some of this terminology.
I want you to think of this whole field like a giant onion. The outermost layer, that's artificial intelligence. This is simply the broad, overarching vision of making computers smart. It's the ultimate goal. But, it doesn't actually tell us how the computer achieves that intelligence. So peeling back and going one layer deeper, we hit machine learning. Now, this is the method. It's the process of feeding massive, and I mean massive amounts of data to algorithms so they can start to learn and recognize patterns totally on their own. This way, a human doesn't have to sit there explicitly programming every single step of a task.
And finally, we get to the innermost core, deep learning. This is a specific subset of machine learning that's inspired directly by the architecture of the human brain. This right here is where the heavy lifting math actually happens, and it's exactly where we're going to focus our journey today.
Section 2. The core artificial neuron, the fundamental building blocks of deep learning.
Okay, to really understand this math, we have to look at the fundamental building block of the whole system, the artificial neuron, which is sometimes called a perceptron. Now, I want you to think of this neuron as a tiny, highly specialized mathematical calculator. It takes in inputs, and those inputs could be the individual pixels of a photograph or specific words in a text prompt, and it assigns them weights. A weight simply tells the neuron exactly how important that specific piece of input data is. After that, it just adds a constant value, which we call a bias, to adjust its threshold. Let's just slow down for a second here and look at how this actually calculates. The neuron multiplies each input by its corresponding weight, and then it adds that bias threshold. Mathematically, it's just this simple linear equation, z equals the sum of x times w plus b. That's it. It's incredibly simple math. It's just being processed over and over and over again.
But, here's the catch. A simple, linear straight line cannot accurately model a super complex world like human faces or nuanced human speech. It's just too simple. So the absolutely crucial point here is that we need a mathematical gatekeeper, which we call an activation function. Functions like ReLU take that linear sum we just calculated and they sort of squash it. It essentially says, hey, if the number is negative, turn it to a hard 0, but if it's positive, keep it. This creates a nonlinear transformation, which is what actually allows the network to learn those incredibly complex, nonlinear patterns.
Section 3. The 3 pillars of AI math. This is the math governing millions of neurons at once.
To give you a really structured framework for the math we're about to explore, think of it as resting on 3 main pillars. First, linear algebra, which is essentially the language the AI speaks. Second, calculus, which acts as the engine of learning. And third, probability and statistics, which provides the underlying logic. Let's look at exactly how they function together.
First up, linear algebra. You have to remember, AI does not see images or text the way you or I do. It processes all data as 2D grids of numbers, known as matrices and column vectors. When an AI looks at an image, what it's really doing is just performing billions of matrix multiplications every single second. This perfectly explains why AI relies so heavily on specialized computer chips like GPUs, because those chips are explicitly built to do matrix math incredibly fast. Okay, moving on to the second pillar, calculus. Now, how does the network know if its weights and biases are actually, correct? Well, it calculates its mistakes using what's called a loss function to find the error.
Think of this function as a really hilly, uneven landscape, where the absolute lowest valley represents 0 mistakes. The AI uses derivatives from calculus, specifically a technique called gradient descent, to slowly find its way down to that bottom valley and figure out exactly which direction to adjust its weights.
And this brilliantly illustrates our third pillar, probability and statistics. You see, AI rarely deals in absolute certainty. Instead, it operates entirely in statistical likelihoods. When a vision model identifies an animal, it uses probabilistic functions, like softmax, to output a probability distribution that adds up to exactly 100%. So it's not stating, this is definitively a cat. It's actually stating, there is a 94% probability that this is a cat.
Section 4. The ultimate learning loop. Let's synthesize all this math.
Let's walk through this whole loop sequentially. When you feed data into an AI, it flows forward. Linear algebra multiplies the matrices, the activation functions trigger the neurons, and probability gives us our final prediction. This is step 1, forward propagation. Then, step 2, we calculate the error using our loss function. And finally, step 3, if the prediction is wrong, the network uses a process called backpropagation to essentially pass the blame backward.
Let's take our time here. Just look at the formula making this happen. Backpropagation relies on the chain rule from calculus. Mathematically, the loss variables directly interact with our weight variables. Using this, the network calculates exactly how much each individual weight contributed to the final mistake. It literally passes this blame backward through all the layers of the network, automatically updating every single connection by just a tiny, tiny fraction.
And you know what? That is the big secret behind the curtain. This exact loop happens millions, sometimes billions of times during the training process. With every single example fed into the system, the math gently adjusts those dials until the network becomes incredibly accurate at its assigned task. Ultimately, learning is simply the optimization of numbers.
So, the next time you see an AI generate an astonishing piece of art, or maybe write some flawless code, just remember what's actually happening right beneath the surface. It really isn't a human mind trapped inside silicon. It is just the elegant, beautiful execution of linear algebra, calculus, and probability. Thank you so much for joining me on this explainer. I want to leave you with one final thought to reflect on today. What part of AI math surprised you the most? Keep learning.